Let's take a look at this example. Please notice that on the left side of this equation we have the product of the sine of the sum of two angles and sine of the difference of two angles. And of course I'm going to start from the left side because the left one is more complex. So what I'm going to do first, I'm going to copy this side down. I have sine alpha plus beta times sine alpha minus beta. Next, I'm going to use this formula for the sine of the sum of two angles and the formula for the sine of the difference of two angles. So this is going to be equivalent, I'm talking about sine right now, sine alpha cosine beta plus cosine alpha times sine beta. I'm finished with this part. Now, I'm going to put them inside of the parentheses. Times, now I have the sine of the difference of two angles. That's why I'm going to apply this formula. This is equal sine alpha cosine beta minus cosine alpha sine beta. Now, I want you to look at the expressions inside of the parentheses. I have sine alpha cosine beta and I have sine alpha cosine beta. They are identical. And I have cosine alpha sine beta cosine alpha sine beta. They are identical beside the signs. So this is nothing else, just the difference of two squares. Okay, let me remind you that the difference of two squares looks like this. I'm going to write over here in order to save the space. And I have a square minus b square is equal a minus b, and I have a plus b. Okay, so this is going to be my a. I can say this is my a, and this is my b, and this is my a, and this is my b. So I can rewrite this as sine alpha cosine beta square minus cosine alpha sine beta square. Next, I'm supposed to apply the properties of exponents and rewrite these expressions as sine square alpha cosine square beta. Simply rewrite this as this minus, you have to apply the same property over here, cosine square alpha sine square beta equals. Please notice that the right side of my original equation contains only signs. Okay, so we have to eliminate these cosines. We have to end up with signs only. So what we are going to do, we are going to use the Pythagorean relation, which says that sine square theta plus cosine square theta is equal 1. We're supposed to eliminate these two cosines. So we have to solve this relation for cosine. So what I'm going to do, I'm going to simply move this sign to the other side. And I'm going to end up with cosine squared theta is equal 1 minus sine squared theta. Okay, so what I'm going to do right now, I'm going to rewrite this part as sine square alpha, and instead of cosine square beta, I'm going to write 1 minus sine square beta, close parenthesis, minus, again I have cosine, that's why I'm going to use again the same relation. Instead of cosine square alpha, I'm going to write 1 minus sine square alpha times sine square beta. Okay, please notice that we do not have cosines anymore. Next, we're supposed to just perform the multiplication. We're supposed to distribute this sign into the parentheses and this sign into the parentheses. And let's take a look what we are going to have. Sine square alpha times 1 is equal sine square alpha. Sine square alpha times negative sine square beta is equal sine negative sine square alpha times sine square beta. Okay, I'm finished with this part. And now I have negative sign over here. Don't forget about this negative sign. Sine square beta times 1 is equal sine square beta and negative, that's why this is going to be negative sine square beta. And I have sine square beta times negative sine square alpha is negative sine square alpha times sine square beta, but this negative sign multiplied by this sign is going to give me positive plus sine square alpha sine square beta. Okay, remember you cannot forget about this negative sign. Now let's combine the like terms. I have negative sine square alpha times sine square beta, and I have positive sine square alpha times sine square beta. That's why these two terms are going to subtract each other, and we are going to end up with 0 with both of them. And we are going to have the final expression as sine square alpha minus sine square beta. Remember, these two subtract each other. That's why we have 0, but we don't write this 0. And we're left with sine square alpha minus sine square beta. Now, please compare this expression with right side of our original equation. Both of them are identical. So it means that the left side of my equation is equal to the right side.